is Mike Havey from MarkLogic Consulting Services. In this video, I would like to introduce a tool that I've written called UML2ES. UML is the Unified Modeling Language. It's a notation for system design. It has its beginnings in OO, or Object-Oriented Design. It goes back about 2 decades. One feature of its notation is the class diagram, which is a particularly effective way to depict the structure of data. ES is Entity Services, the model-driven approach within MarkLogic. So ES includes a JSON descriptor format for representing a data model, as well as code generation capabilities to allow you to generate code from your Entity Services model. UML2ES, which is this toolkit, converts UML to ES. The great advantage of that is that there are many tools out there for UML, say that you can model your data in one of these UML tools and then make it into some real thing which you can actually leverage within MarkLogic once it's in ES form. So this toolkit, in addition to having that conversion capability, has tips, examples, and tutorials on how to actually model data using UML for MarkLogic. And it emphasizes the mixed modeling approach, which is document-oriented design with semantics. MarkLogic is a NoSQL database where its sweet spot is particularly in that area, document-oriented plus semantics. There's also 3 blog posts currently published on this tool. And if you want to download the tool, you can find it on GitHub at this location. So now let's discuss motivation. Why this toolkit? And it is simply to enable data modeling for MarkLogic DB. If we think back, in the days of relational databases, we did lots of data modeling. We would use an off-the-shelf ERD or UML tool, produce a big poster-sized data model of our relational database. You might argue that times have changed, that we don't do big modeling up front anymore, and that in any case, we did that modeling for relational, and if relational is dying and we move to NoSQL now, isn't it the case with NoSQL that we can adjust anything regardless of structure? If that's so, why model? Well, I think this is wrong. Modeling is beneficial for MarkLogic. And one way to think of it is in terms of the data hub pattern, which is a very common one in MarkLogic. If we're using MarkLogic as a data hub, it's true that we stage just about any kind of data regardless of its structure. In fact, we don't even necessarily completely understand the structure until after we've staged it. So true, we don't need to model data in staging, but staging isn't all there is to a hub. We harmonize the staging data to a canonical form. That form we want to understand in terms of a model. And that's the sweet spot of this toolkit. And in this video, I want to show this by example with respect to a particular tutorial. I'm going to show highlights of that tutorial, but I encourage you to try this at home, to obtain the toolkit and to work through the tutorial step by step. So let's jump into the tutorial. And that tutorial is, I'm showing it here in the browser. This is part of my GitHub repo. We're going to be designing an employee department database, the human resources department of a firm called Global Tech. Imagine you are the development team for this project. This diagram shows the people involved as well as what they're going to build. And you're going to, in doing this tutorial, play the role of all of these stick men. So most importantly, you'll be the data architect who uses a UML tool to design this employee department model. The tool we're going to use, by the way, is Papyrus, which is an open source Eclipse-based tool. The other tool I use throughout this toolkit is Magic Draw, a commercial UML tool. You're going to have MarkLogic in the picture, so you'll need to have MarkLogic up and running. And as part of this, you'll be setting up a data hub, which consists of the staging and a final TP. This is where we will have the employee data. You will be the developer who develops the harmonization code to produce employee data that conforms to this UML model. And you're also going to ingest that data from various sources into a staging database. You will be playing the role of the source data SME, subject matter expert, who really understands this source data and who documents in a spreadsheet how to map that source data to this model. And finally, you'll be the build person. Now, this aspect of the tutorial might seem a bit mundane, but getting the build right is important. In particular, we want to get a Gradle build that, first of all, is able to stand up this hub properly and is also able to incorporate the UML2ES Toolkit. So there's 5 steps. Step 1 is to actually stand up the environment. Here you would wear the hat of the build person. And you basically want to get these databases stood up. You also want this transformation piece, which converts UML, the UML model, to the entity services model in MarkLogic. That needs to be part of your build as well. So ultimately, you are putting together the folder structure for a Gradle project. The top level is called Employee Hub, and it contains various things. The ML Profile project, whose purpose will become clear in the second step of the tutorial. This is not something you need to write, but this is something that's part of the UML2ES Toolkit that you import in. And then we have a big source code folder here called XMI2ES. Again, you don't write this. This gets brought in from UML2ES. This is actually the piece that does the conversion from UML2ES. And there's a Gradle file here called UML2ES for dhf.gradle. This is a set of Gradle tasks to actually run that transformation. And the overall structure here is a Gradle structure that's meant specifically for the Data Hub framework in MarkLogic. And this build.gradle file, which you get as a starting point for running this tutorial, is meant to assemble a Data Hub. So that's step 1. It's a bit of a sunk cost. You need to get something going early on. But the fun starts in step 2, where you get to wear the hat of the data architect and build a UML model. I have Papyrus up and running. The steps of this, if you expand this, the steps that you would follow at home tell you everything you need to do screen by screen, click by click, to put together the model. I won't do that for you, but let me show you what you end up with. The model looks like this. So this is a UML class diagram. We have 2 main classes, department, employee. Each one has attributes. So employee, for example, has employee ID, first name, last name, and so on. There are relationships. So you can see that employee is related to department through a relationship called member of. And in UML, we call this an association relationship. So an employee is a member of a department. We also see an association between employee and itself called reports to. So one employee reports to another employee. And we have some subordinate classes here. email, phone, and address. And just to show the packaging flexibility of UML, we define these in a separate package. You can see here the structure of address, phone, and email. And there is a shared aggregation relationship. That's this arrow with a diamond on the end. So employee contains instances of address, or put it another way, employee has addresses. One other aspect of the model is the use of stereotypes. These are these things with the double angle brackets. A stereotype is a way of decorating the model, of giving additional information about classes and attributes. And it's UML's way of extending a model. It's a standard way in UML of doing that. What you need to do to use stereotypes is to have a profile. And that's what this ML profile project is here. This is something that's provided by the UML2ES Toolkit. You don't need to write this yourself. You just need to import it in. XDocument is a class-level stereotype. What we're saying here is that employee has some additional things that are expressed through this XDocument. And these include collections, permissions, quality, and metadata. And in particular, what we're saying is that employee is meant to have a collection called employee. So when we actually represent this employee physically in MarkLogic as a document, it should have the collection employee. One of employee's attributes is URI, which has the stereotype X calculated. And if we look here, we see that this is defined as the concatenation of three things, of a string /employee/ of the actual attribute employee ID, which refers to this, and the string.json. So when the employee is represented as a document in MarkLogic, its URI should be the string concatenation of these three things. So that concludes step 2. Step 3 is to actually deploy this to MarkLogic. So 3 people cooperate to do this. The build person executes the Gradle that takes the UML model and deploys it to MarkLogic. The data architect watches this happen and makes sure that what ends up in MarkLogic conforms to the model. And the developer watches this also, because the developer needs to build the harmonization logic to ensure that we have canonical employee data that conforms to the model. We ultimately run one pretty brief command called employee HR model to do this. The tutorial describes the mechanics of that. But what you end up with after running that are a couple of things. First of all, this is a screenshot of the entity services model that gets deployed to MarkLogic. So this is a real thing in MarkLogic. It's what started as just a picture in UML here is now this JSON structure that lives in MarkLogic. And if you look at it, compare the structure. So here, employee has properties, employee ID, first name, last name, status, and so on. And here in UML, employee class has attributes, employee ID, first name, last name, status, and so on. So the data architect will be happy that what's living in MarkLogic's entity services model conforms to the UML model. Now, in addition, there's some generated code, and here's a snippet of it. And this is where the stereotypes come into play. So we see, for example, in this first JavaScript function, run writer employee, when we actually persist the employee as a document of MarkLogic, we'll make sure that it has the collection employee, And that, of course, as we just saw, comes from this X document stereotype on the employee class. That's why that's there in the generated code. When we construct the URI attribute, which is a calculated attribute, it's the string concatenation of these three things. Where does that come from? Well, as we just saw, the URI attribute is the concatenation of these three things. So that's what the model said it should be, and we have code that generates it, that generates the URI according to that. So step 3 is to deploy that model. Step 4 is the mapping spec. Recall that we have the source data SME who understands all the source data that will get staged in MarkLogic. This data does not conform to the model at all. It is what it is. It comes from legacy backends, and Global Tech has its own kind of messy way of expressing employees and departments. And to confound matters, Global Tech recently bought another company called Acme, which has its own way of representing these things. The source data SME has the knowledge of this source data and understands how to map it to this model. And he or she expresses that in a spreadsheet. By the way, the template for this spreadsheet is in the UML2ES Toolkit. So the source data SME takes that template and fills it in. First of all, let's look at the source data itself. So here is how Global Tech represents its employee data. It's a CSV file, and you can see that there's lots of columns. Each row represents an employee, and the columns are the attributes of the employee. And most of the employee data is in this CSV, but there's an additional CSV called the salary table, which has salary data for the employee. So we refer to two different sources to build the global corp representation of an employee. Now let's look at the mapping spreadsheet. So here is the data mapping for the global corp employee. So we have the mapping source as the employee table.csv, the salary table.csv. And then starting on row 13, we have the field by field mapping. Column A are attributes of the UML model. Column B are the corresponding attributes in the source data. Column C are mapping notes, which are meant to be taken into account by the developer. So some of them are obvious, like employee ID from the model is emp_ID in the source data. Effective date from the model is job effective date from the salary table. So when doing the harmonization, the developer will need to look at the spreadsheet and figure out how, based on this spreadsheet, to map data to the final form. So that concludes step 4. And by this point, the developer has what he or she needs to proceed. He or she has knowledge of the source data thanks to the source data SME, and has a data model for the final database representation of the employee thanks to the data architect, and has a build process thanks to the build person. So step 5 is quite a substantial step. It'll take you the most time of any of the steps. But let's just show some of the highlights. First of all, we need to ingest the data into staging. And let's look at that just by going into Query Console and looking at that staging database. So here we see, for example, HR employee global 122, and it is just a JSON representation of a row in that CSV file. It does not conform to the UML model. Let's look at a salary document. HR salary global 1. Just a JSON representation of the row from that CSV. Let's look at where we want to end up while we're here. Here's the final database for the hub. If we explore this, we'll see employee 107.json. And here, this JSON actually conforms to our UML model. So if you look at this structure, and then you go back into UML and look at this structure, you'll see that it conforms. So that's great. Not only does it conform to the model, but we got the data from this messy staging. How did we do that? Through a process called harmonization. So the first thing we need to do is to generate some boilerplate code for the harmonization. And luckily, we can do that generation thanks to Entity Services. We don't need to actually write that all from scratch. And in the tutorial, there's one particular step that says how to do that. And it's just a simple command like this, a Gradle command. This comes out of the box with MarkLogic Data Hub. You don't even need the UML2ES Toolkit to run this. But it creates a harmonization flow called Harmonize Employee Global. And it uses the Entity Services representation of the employee. With the knowledge of this model, the harmonization, if you think of mapping source to target, well, it knows everything about the target. So it has that code for you. You just got to fill in the source part of that source to target mapping. Now, source to target, we know the target, and the source side of it, we have some help because Source SME has produced this spreadsheet. So it all becomes pretty easy at that point. Let me show what some of that code actually looks like. All right, so we see, let's just look at this block of code from 49 down to 54, let's say. We've got content.employeeID equals instance.emp_ID. So guess what? The left side is the UML model. The right side is the source data. Content.firstName equals instance.first_name, and so on. And we put in a comment here in our code using SME mapping. We didn't have to make this up. We looked at the SME spreadsheet to figure out basically the right side of all of these assignments. So that's basically the tutorial. And the tutorial gives detailed instructions on how to assemble this code. It gives you pointers on exactly how you would write this. Now, just to conclude, this HR tutorial, employee department tutorial, is pretty basic, but there's a more advanced example in the toolkit that I've also written a blog post about. Here's the link to that blog post. With a similar HR data model, but with semantics and more advanced code generation in it. I'm just going to quickly show what that model looks like to give you a flavor of the semantic aspects of it. And by the way, when you run through this tutorial at the bottom, it links you to that example. So here we have the HR model covered by that blog post. And here, some of the relationships we express semantically. So for example, employee is a member of a department. But in that example, we express that relationship semantically using the semantic predicate org member of. Similarly, the relationship of an employee to itself reports to is in terms of a semantic predicate org reports to. So there's the semantic aspects of this, the mixed modeling, document, and semantics together. The other thing is the code generation. So what this example shows is how to take the SME comments and actually incorporate them into your harmonization code. In the tutorial, we looked at the SME mapping to write harmonization. In this example, we actually embed the SME mapping as comments in the harmonization. We also do something called discovery, which means looking at the data that's already been staged to try to figure out, based on certain data patterns, what some of those mappings might be. So that's all more advanced stuff. Don't want to talk about it here. Just want to let you know that it's there, and this might be something good to look at once you've gone through the tutorial. That's all I have. Thank you very much, and please feel free to reach out to me with any questions.